All right, so this time we're going to dig a little bit deeper into what happens when you get paid forever, and then we'll use all of the things we've talked about so far in this week's lectures to solve some problems. So first, remember our situation was we had $2, $2, $2 every year for forever, and so that situation is described more generally in line 1 here in this setup. So we would say we want to know what the present value is, and the present value of those payments is $2 divided by 1 plus r, right? That's the present value of a payment in year 1, plus $2 divided by 1 plus r squared, right? That's the present value of a payment in year 2, and then plus dot dot dot. Why? Because, right, this pattern will continue forever. Now there's some algebra here that gets a little tricky. So it's here in the video. You can pause it and follow it if you're inclined. But I think you can also decide just to trust it and see where we end up, right? So skipping down to the bottom there, we get that the solution to the present value of the same payment over and over again is that payment divided by the interest rate. It's actually a very simple formula. It's even simpler than the present value of one payment. So in our case, we had $2 at 2% interest, so it's $2 divided by 0.02, and we get 100. So notice, because we're not dividing by 1 plus r, we're dividing by r, it actually makes the numbers get quite a bit bigger. If I had $2 at 1% interest, it would be 2 divided by 0.01, and you'd get 200. So we call getting paid forever and ever, we call the thing that does that a perpetuity, as in perpetual, like perpetual motion machine. So a perpetuity is a security that pays periodically the same payment forever, and the value of a perpetuity is C over R. So I told you there's about 5 or 6 formulas depending on how you count, and this is number 3. So we have a perpetuity formula where getting the same payment over and over again has a present value of C over R. So let's do an example. So if I have $10 every year for forever, and the interest rate is 10% per year, compounded annually, because my payments and my interest rate match, right? You heard me say $10 every year and 10% every year, year, means I can just put it in the formula, and I would get 10 divided by 0.1 and get $100. So if interest rates fall, $10 divided by 0.08 is 135. And that also points out a really key feature of bonds, and that is as interest rates fall, bond prices rise. And so if you know your history a little bit, back in the early and mid 80s, the United States had very high interest rates. And so in the 11-12% range for short-term loans, and now the interest rate for short-term loans is very close to 0. So what happened when interest rates went from 10% down to close to 0% is that bond prices rose fairly dramatically. Nothing really dramatic happens in bonds ever, but if you look over a 30-35 year history, we have an incredible bond market performance. And so this has had a pretty significant effect on the financial markets, as well as some aspects of personal finance. So in particular, durable goods purchases, because they have significantly less credit risk. Right? If I buy a car and I don't make my payments, they just come get the car, and there's not a lot of loss for the seller. Same with the house. You foreclose and the house is still there. And so for those durable goods kind of purchases, the interest rates have declined very significantly since the 80s. So here's an example for you to try. We have $8 every year forever. The market rate is 3.8% per year compounded annually. and you should get $210.53. So go ahead and try it. See if you can get that on your own. Okay, and here's another example, 5 forever at 5%. What should that be? So you can use the formula, or also intuitively, right, we have 5 divided by 0.05, that should come in right at 100. And so it's just because 2 divided by 2% was also 100. And logically, right, if I cut the interest rate in half, what's going to happen to the price? Figure that out. Right, if it cuts the interest rate in half, then the price should double. So now, let's go back and do some Bob problems and take this to the next level. So now we know that if Bob offers us a payment every year for forever, we can find the value. And so we've got our situation here where we have it's 10 years have passed, and he's offering a $5 perpetuity. So $5 every year. Market interest is 5%. And so at this point, right, we can apply the perpetuity formula. We get 5 divided by 0.05, and the value is 100. And that's just an application of the perpetuity formula. So 5 forever is worth 100 at 5% interest. But now let's make this a little more interesting. What if we do this today and not 10 years in the future? So today, we're looking at a bunch of zeros. We're looking at 10 zeros in the future. And then finally in year 11, we get some money. And don't forget, we know that in year 10, the 5s to forever are worth 100. That's what we figured out in bullet point 1. So we know that the security is worth 100 in year 10. All right, so let's go to Excel here and make a little map of this. So we know that 5 forever is worth $100 in year 10. And we want to know, what is it worth in year 0? I don't know if I need to put question marks at the beginning and the end. So we're double questioning. Okay, so we have $100 in year 10. We want to know what it's worth in year 0. Well, we can do the same thing we would do anytime we're trying to move money through time. We'd say equals 100 divided by 1 plus r to the n. 1 plus r to the n. 6139. Right, that's it. Right? That's the present value formula applied. So once again, we're doing multiple steps, right? 5, this whole problem would look like this, right? 5 divided by 0.05, right? Cash flow divided by rate, and that quantity divided by 1 plus r to the n. Value of the perpetuity, present value of the perpetuity. Same answer. Okay. So now let's make things really fun. So we're going over 9,000 with this. So what if Bob offers to sell you a perpetuity that starts paying immediately? So no more of this waiting business. We get paid. So we're going to get 5, 5, 5, 5, 5. But now he's going to mess with us, right? So now he's going to say, okay, after 10 years, you have to give it back. So we don't get it forever. We just get it for 10 years. 5, 5, 5, 5, 5. Okay, so let's break this up into 2 parts. Let's break this up into 2 parts. So what do we get? What we get is easy, right? We're getting a perpetuity. It pays 5 forever. So what is 5? Oops, 5 forever. We know that. It's $100, right? $100 at 5% interest. Okay, 5 divided by 0.05. Oh. Okay, so the key to this question then is what are we giving up, right? We get a 5 forever that's easy to value, but then we give it back, and then we give it back. So what is the value of the thing we give back? Well, the thing we give back pays forever, right? It's a 5 forever. It's exactly the same. So what do we give back? We give back a $100 thing. Okay, so we get $100 and we give back $100. So the value to us is, well, it's tempting to say it's 0, but we know this is not the case, right? I'm getting 5, 5, 5, 5. I'm getting 5 10 times. This has a value. So what am I giving back? Well, I am giving back 100, but the key is I'm giving back 100 in year 10. Okay, so we can actually think about the value of us getting this security as 100 in year 0 minus 100 in year 10. Now that's like saying 100 Ferraris minus 100 ketchups. You can't do it. So we need to convert from one to the other. And in fact, we've already done that. Right here, we had 100 in year 10. We found to be worth 61.39. So actually, this is 100 in year 0 minus 61.39 in year 0. So do you see how these are actually the same thing, these two lines? This one is 100 in year 0 minus 100 in year 10. This one is 100 in year 0 minus dollar sign here, 61.39 in year 0. All we've done is do an interest rate conversion. It's like, you know, going from Celsius to Fahrenheit. So we've converted this now to year 0, and since we have year 0 in both cases, we can do 100 minus 61.39 and get the value right there. So that is our value in year 0 of getting $5 for 10 years. So you can think about this in general. In the general case, you would say for some cash payment C, I guess cash flow divided by R is the first part. That's what we get, and then we give up cash flow divided by R divided by 1 plus R to the n. Right, I have a perpetuity that I get and a perpetuity that I give up, only it's later. Okay, and what does this do? What does this do? What does this do? Well, this tells us what is the present value of n payments. Right, if I get a payment every year, then this is n payments. This is the present value of n payments. And this is huge. This is huge. Why? Because, right, what kind of things in your life have payment done? Right? Lots and lots of things. I bought a house on Thursday, and I have a mortgage. It has payments. I will pay payment till 30 years have gone by, and then I'm done. Right? If you buy a house or a car, you probably might have 5 years or 4 years or 3 years of payments every month until you're done. So using this, right, using the logic of the time value of money, we have a formula for the value today of any series of installment payments. Right? We can say I'm willing to pay, right? So I'm willing to pay, say, $1,200 a month, right? I'm willing to pay $1,200 a month. My monthly interest rate is 0.5%, right? 6% a year. What is the, how much, right? How much house can I afford? So I would say payment divided by rate minus payment divided by rate divided by 1 plus rate to the, okay, and how many payments is 30 years? Well, it's 30 times 12. So 3 times 12 is 36, so 360. So if I'm willing to pay $1,200, I can have a budget to purchase my house of basically $200,000 even at 6% rates. Now, of course, that's neglecting taxes and homeowners insurance and mortgage insurance and all the other things that happen. But just see how quick that was. This is really powerful stuff. We can take a payment and back out the value that's available. It's same and naturally, right? If I buy a $200,000 house, I could use Solver and find what payment would be appropriate. So, long story short, doing this kind of thinking gets us another formula, right? Our fourth of 6. We get the annuity formula. It looks just like we had it in the Excel, and you can apply it directly to problems. So if I have $10 for 10 years at 5%, I would say 10 divided by 0.05 minus 10 divided by 0.05. So those are the two perpetuities. One of them is delayed 10 years. Simplify, and you get $77.22. So, and that's it. So between the present value formula, the future value formula, the perpetuity formula, and the annuity formula, you can do a wide spectrum of questions and problems. Right, a key feature to remember is that if I have, say, a perpetuity, I might use the value of the perpetuity and then take the present value of that. Right? The annuity formula itself is a perpetuity minus the present value of a perpetuity. So there's a strong thread in the thinking around time value of money of nesting your functions, daisy chaining your inputs, right? This output becomes input in the next thing, which becomes input in the next thing. And that's how we get to complicated problem solving. So, for example, corporate bonds are actually the combination of an annuity and a lump sum payment, which means we can treat a bond as an annuity plus the present value of a cash flow, and an annuity itself is a perpetuity and a delayed perpetuity. So really a bond is a long interest, right, a purchase of a perpetuity, a sale or short interest of a delayed perpetuity, and a purchase of a delayed payment. You combine those three things together, we can replicate the cash flows of a corporate bond and do bond valuation. And that's we're not going to do that yet, but we will in a couple of weeks. So so that is in essence the thinking behind time value of money. So that, I guess, introduction and walkthrough and thinking should be enough to get you started. And when we come back, we'll work on some problems that use this kind of thinking.